subsequence II. So before we are solving this problem, let's just solve the previous problem first. As I've already solved the previous problem, so let me just copy and paste the same code. Yeah, I will not copy the code, but let me just explain the problem. Yeah. So for problem 1, actually we are given a string and we are going to calculate the longest palindromic subsequences directly. There's no other conditions. We just need to check what's going to be the longest palindromic subsequence. Yeah. But for this problem, there are going to be a lot of constraints. So this is okay. It is a subsequence of S. So the second constraint is it is a palindrome. So it is similar like before. And now we have another constraint that is different from problem 1. It has even length. And the second condition is no two consecutive characters are equal. Yeah. So based on problem 1, for this problem 2, we just need to check how to solve the following two other cases. Yeah. And in this example, so for example, in this string, it's going to be A, B, B, A. Because A will not equal to B, it is valid. Only this B and B can equal. But for this A and B, it must not equal. Yeah, so for example, if it is B, 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 definitely it's going to be invalid because this B equal to this B. Only in the middle two B's, those B's can equal. But for this B and this B, it cannot equal. So this is what we are going to check. No two consecutive characters are equal. Yeah. So let's just use the same idea to solve the problem. So the length of the string is 250. So this means maybe this is a DP problem, and it's gonna be 3 dimensions. Because for 2 dimensions, we're gonna solve the problem like this. It is a subsequence or it is a palindrome. It is even length. It is also okay. But how can we check no two consecutive characters are equal? So definitely we're gonna need another dimension. So this is a 3D DP problem here. And by using DFS with memorization, it's gonna always be easier to solve. Yeah. So let's just write the first 3 cases. It may be easier to write. So from I to J, as it must be even. So how can we check it must be even? So if I gonna always be less than, I gonna always be less than J. But if I is more than and equal to J, what's gonna be the condition? So we're gonna return 0. So this is for character A. If we are having a character A, definitely we're gonna return 0 because there's no odd cases. If there's no character, so definitely we're gonna return a 0. So this is what we are doing. Yeah. Now we are going to check the 2 other cases. So we're gonna set a result if Si equal to Sj. So the result is gonna plus equal to DFS with I plus 1, J minus 1 plus 2. Else result is gonna plus equal to the maximum of the DFS I plus 1 to J and the DFS I to J minus 1. Finally, we're gonna return the result. Yeah, now let me just run it to check if it works. Currently, we didn't check the last case, no two consecutive characters are equal, but it is still okay. Let's just check if it works. Yeah, at least we can pass for some testing cases. For testing case 1, it is okay. We're gonna return an even value 4. For the second case, we return an even value 6, but it should be 4. This means we found some consecutive, 2 consecutive characters. This is why it is wrong. Now we just need to finish the last condition. Yeah. How can we check this condition? How can we check the 2 consecutive characters? So for example, this is in the middle, AA. Yeah. But at this side, there's another character. Maybe this is B. B is not equal to A. It is okay. Maybe this is another A. How can we check that? Yeah, we're gonna use a variable, previous. This means the previous character. This is gonna always be easier to write because inside the DFS with memorization, it's really easy to check the different conditions. Even we add a variable previous. Yeah. So from the beginning, we're gonna set a previous as a none. Yeah. You can set it as any other characters. Maybe you can put it as a 0 character. It is okay. But I'm gonna use a none. It means definitely for the first cases they are not equal. Yeah. Now, we are going to check the two characters si equal to sj or not. So from here, so this is a AA, so this is a and for here we have another two characters. So this is b and this is b. Yeah. So now, what is the previous character? This previous character gonna update it to a, and this a gonna compare with this b. Yeah. So from here we're gonna check with the previous character if this si. So where is the si? So this is our yeah. So this is the si. Yeah. So this is the previous character. And this character b is the si. We are going to check if this b equal to a or not. Yeah. They must not equal. So si should not equal to the previous. Yeah. So instead of checking both sides, we are just checking one side that is okay. You see? We don't need to check two sides. We only need to check the left side of the right side that is okay. So this means all the characters are not equal. All the consecutive characters are not equal from the left side. How can we check that? We can just use the previous with si. Yeah. If they are not equal, so here we're gonna update the previous with this si. So this is gonna be the new previous characters because they are not. Yeah, let me think about it. Yeah, this is gonna be the new characters. For this b, gonna be the new characters, new previous characters. Then we're gonna might check another character. Maybe this is c and c. Yeah. So otherwise, if they are not equal, we're gonna keep the previous character. It's gonna be the same as before. We're gonna keep it. Yeah. So this is for the case. This is a, and this is a. Here we have another a, and here we have another a. Yeah. Even though they are equal, this a equal to this a, but this a equal to the previous character. So what are we gonna do? We will not update the final result. It's gonna be the same as before. We will not update it because this a equal to this a. Only if this a not equal to this a here, then we're gonna update it. So yeah. So this is from here. We are not updating actually. Now let me just run it to check if it works. I did something wrong. The previous should be inside, not outside, right? It's gonna be here. Yeah. Now let me just run it. Now as you can see it works, and let me just submit it. Yeah, as you can see it passed. Although it is not so fast, but at least it works. We use the dynamic programming, and the time complexity gonna be 250 square. This is for I and j, and this previous it's gonna be 26 characters, so it's gonna time 26. So this is gonna be the final time complexity. That is why it is a little bit slower, because according to this value, it's gonna be a really big number. So maybe let's just print out what is gonna be this number. 250 times 250 times 26. It must be a very big number. Yeah. So as we can see, it's gonna be something like 1 times 10 to the power of 6. That is why it's so slow. Yeah. Basically, I think that's all about it. Thanks for watching. See you next time.